Hi, I'm Matt, and in this video we're going to talk about how to take derivatives using the quotient rule. So first off, what is the quotient rule for derivatives? So the quotient rule, as its name implies, is going to be used when we have a quotient, or more specifically, the function f of x we want to take the derivative of is written as the quotient of g of x over h of x, or written mathematically, f of x is equal to g of x divided by h of x. When we get a function in this form, that's when we'll know to use the quotient rule. And the quotient rule says that the derivative of g of x divided by h of x is equal to g prime of x h of x minus g of x h prime of x divided by h of x squared. So this here, bordered in green, is our quotient rule for derivatives. You'll notice that the numerator looks very similar to product rule, with the difference that we have a minus in the middle rather than the plus we would have in product rule, and now we have something in the denominator. I would also caution you that remember that subtraction is not commutative. So when you use the quotient rule, definitely make sure that your g prime of x h of x is the first term and that your g of x h prime of x is your second term in the numerator. Otherwise, you're going to end up with the incorrect sign. With that said, now let's move on to the steps. So how specifically can we use the quotient rule to compute derivatives? So first, we're going to write f of x is equal to g of x divided by h of x. That will just define what g of x and h of x is for when we look at our work, and just show that we're recognizing that f of x is a quotient. Next, we're going to want to identify what the numerator function g of x is, and identify what the denominator function h of x is. And then from there, remember that now we're going to need the derivative of our numerator, or g prime of x, and the derivative of our denominator, h prime of x. So those we will compute by taking the derivative of g of x and h of x respectively. Once we have that, we have all steps 2 through 5. We have all parts for the quotient rule. So we're going to write the quotient rule just exactly as you see it here. So just write the quotient rule in terms of functions. And then in step 7, we're going to plug the results from steps 4 and 5, and actually steps 2 and 3 into the quotient rule. Just plug everything in and simplify. And from there, we'll write our final answer as f prime of x is equal to our simplified result from step 7. So now that we've said that, we can now try an example. So here we're asked to find the derivative of x squared divided by 2x minus 5. Clearly we have a quotient here, so we're going to want to use the quotient rule. And to do that, we're going to start off by just writing that as a quotient. So we're going to write f of x is equal to g of x divided by h of x. Further, now that we've done that, we want to identify what g of x is and what h of x is. Remember that g of x is our numerator. So since g of x is our numerator, we could take g of x to be x squared. Similarly, h of x is going to be our denominator. So h of x is going to be 2x minus 5. Now that we have g of x and h of x, the next step is to compute the derivative of the numerator and the derivative of the denominator. So to start off, we'll take the derivative of the numerator, or take the derivative of g of x. Since g of x is x squared and x squared is a polynomial function, we can use the power rule to take the derivative of x squared. And the power rule says that the derivative of x squared is 2x. For h of x, we have 2x minus 5, and 2x minus 5 is also a polynomial. So we could use power rule on each term in h of x to get h prime of x. And doing so gives us that h prime of x is 2. And that's just because the derivative of 2x is 2, and the derivative of 5 is 0 because 5 is a constant. Now that we have g of x, h of x, and the corresponding derivatives, we can write our quotient rule and plug in. So again, our quotient rule says that the derivative of our quotient, or the derivative of g of x over h of x, is going to be equal to g prime of x h of x minus g of x h prime of x, all divided now by h of x squared. So now again, the next thing to do is to plug in. So I'm going to write that on the next line and write that d dx of f of x is equal to 2x, because that's g prime of x, then times h of x, so 2x minus 5. And now subtracting g of x, so x squared, times h prime of x, which is 2. And lastly, we can't forget our denominator, our h of x squared. For that, I'm just going to write 2x minus 5 in parentheses squared. And now we're not done, because now that we have it in this form, we want to do some amount of simplification. So to start off, I'm going to distribute the 2x into the parentheses. And doing so gives 4x squared minus 10x. And then from the second term, we have a minus 2x squared. Now all that's left to do is add our denominator again. For a final simplification, I'm going to subtract 2x squared from 4x squared to now get 2x squared minus 10x in our numerator divided by 2x minus 5 squared. And this will be our final answer, so all we need to do is write our answer neatly. And we got f prime of x was 2x squared minus 10x divided by 2x minus 5 squared. For our second example, we're going to look at f of x is equal to 3x minus 5 divided by 1 minus 5x. So the first thing we're going to want to do is identify f of x as a quotient. So we'll just write f of x is equal to g of x divided by h of x. And from here, we now again need to identify what our g of x function is and what our h of x function is. G of x again is going to be our numerator. So in this case, g of x is going to be 3x minus 5. Similarly, h of x we see as our denominator. So we're going to take h of x to be the denominator of f of x, or in this case, h of x is going to be 1 minus 5x. Now that we've identified g of x and h of x, we can then move on to the next step, which is to find our derivatives. So find g prime of x and find h prime of x. Taking the derivative of the numerator to find g prime of x, we can use power rule because 3x minus 5 is a polynomial, and doing so gives us that g prime of x is 3. Similarly, h of x is also a polynomial, so in finding h prime of x, we could also use power rule. And doing so gives us negative 5. And that's because the derivative of 1 is 0 because 1 is a constant, and the derivative of 5x is just 5. We just need to be careful of the sign because we have the minus here. So now we could just plug into the quotient rule. So to do that, I'm first going to just write our quotient rule, which says that the derivative of our quotient, or the derivative of g of x divided by h of x, is going to be equal to g prime of x, h of x, minus g of x, h prime of x. And then we have to include our denominator of h of x squared. And now that we have that, we can plug in. So on the left-hand side, I'm going to rewrite our quotient as f of x. So we'll have d dx of f of x is equal to g prime of x, or 3, times h of x, which is 1 minus 5x. And then we'll subtract g of x, which is 3x minus 5, multiplied by h prime of x, which is negative 5. And then again, we'll put our denominator of h of x squared, so 1 minus 5x squared. Now we just need to simplify. So I'm going to start by distributing the 3 into the parentheses and get 3 minus 15x. And then here I'm going to multiply the negative 5 into the parentheses. And note that the entire second piece here will be subtracted because of the subtraction in quotient rule. So 3x times negative 5 is minus 15x. And then negative 5 times negative 5 is positive 25. And from here, again, we just have our denominator, so 1 minus 5x in the denominator. For our next piece of simplification, we're going to again simplify our numerator. And doing so gives that the derivative of f of x is going to be equal to 3 minus 15x plus 15x minus 25 divided by 1 minus 5 of x squared. And finally, this just simplifies to negative 22 divided by 1 minus 5x squared. And that will be our final answer. So our last step is to just write this neatly and write f prime of x is going to be negative 22 divided by 1 minus 5x squared. For our final example, we're going to do f of x is equal to the square root of x divided by x minus 2. So again, the way we're going to start this out the same way we have previously, and that's identifying f of x as a quotient. So I'm going to write f of x is equal to g of x divided by h of x. And now the next step is to figure out what g of x and h of x are. So again, g of x is going to be our numerator, and h of x is going to be our denominator. Here, square root of x is in the numerator, so that's going to be g of x. And x minus 2 is in the denominator, so x minus 2 will be h of x. From here, we now need to differentiate both of these. Before we differentiate g of x, though, I'm going to rewrite square root of x as x to the 1/2 power. From here, since it's x to the 1/2 power and we have a fractional exponent like this, we could just apply power rule. And when we take power rule to find g prime of x, we'll find that it's 1/2 times x to the negative 1/2 power, or more cleanly written as 1 divided by 2 square root x. And now we also need to differentiate our denominator, h of x. And doing so gives us that h prime of x is equal to 1. And that was again found using power rule. Now that we've done this, we have g of x, h of x, and the corresponding derivatives. We could write quotient rule and plug in. So again, quotient rule tells us that the derivative of a quotient, or the derivative of g of x divided by h of x, is going to be equal to g prime of x, h of x, minus g of x, h prime of x, all divided by h of x squared. And now it's just a matter of plugging in. So we'll plug in g prime of x, which is 1 divided by 2 square root x. And then we're going to plug in h of x, which is x minus 2. Next, we have our subtraction, and we have g of x, which is just square root of x. And then h prime of x is 1. I'm not going to write the 1 here because 1 times square root of x will just be square root of x. And then in the denominator, we just need to write h of x, so x minus 2 squared. And now here, we definitely want to simplify this. We certainly don't want a fraction in our numerator. So the first thing we're going to do to simplify this is to make like denominators. And to do that, we're going to multiply our second term by 2 square root x divided by 2 square root x. And in doing so, we can now rewrite this as x minus 2 minus square root of x times 2 square root of x, and then put the entire numerator over 2 square root x. And then we still have our denominator of x minus 2 squared. From here, there's definitely more simplification to be made, but we'll have that d dx of f of x is now going to be equal to x minus 2 minus, when we multiply 2 square root x by square root x, we just get 2x. And then rather than writing that divided by 2 square root x divided by our denominator, I'm going to pull the 2 square root x into the full denominator, and we could rewrite it like this. So we now have x minus 2 minus 2x divided by 2 square root x, x minus 2 squared. From here, we could simplify it further to be negative x minus 2 divided by 2 square root x, x minus 2 squared. And this is our final answer, so we'll just write it up neatly. And doing so gives us that f prime of x is equal to negative x minus 2 divided by 2 times x minus 2 squared, square root x, where I just brought the square root x to the end. Okay, so this is our final answer. We'll now move on to some extra practice questions. So if you would like, here are 4 practice questions for you to try on your own. The last question, if you know trig functions, I think is a good question to both practice trig functions and quotient rule. The answers to these questions will appear in 5 seconds. Okay, so what I did here is when you plug into quotient rule directly, that's when you get what's written in yellow here. And then the simplified answer is what's written in green. I would encourage you to, if you got the yellow but not the green, to try to sit down and fully simplify it to something close to what I have here. For problem 3, note that you could either write it as x to the 3 halves power or the square root of x cubed. Either is fine. And for problem 4, what I have written here, so 2x secant x plus x squared secant x tan x, that's the preferred answer because that's the most simplified, but what I have written up here is okay too. In this video, the purpose was quotient rule, but the last question can actually be done with product rule as well by writing it as x squared secant of x. Nonetheless, though, here are the answers. I hope you got these. If not, feel free to leave any questions you have about this video or derivatives in the comments below. Thank you so much for watching. Have a great day.